session I'm going to discuss about first unit only. First unit only. Tomorrow, second unit. Day after tomorrow, third unit, first half. So, one, two, three. These three sessions I'm going to utilize for revision only. Okay. Unit 1, Introduction to Quantum Physics. Already you know. Unit 2 is Band Theory and Energy Bands in Solids. As two chapters it has. And Unit 3, if you take, only first portion, first half only is the syllabus for the mid examination. That is about the semiconductors. Today, Unit 1 I am going to explain. Okay. So Unit 1, if you take Introduction to Quantum Physics, these are all the topics that we are having actually. Okay. What we discussed under Unit 1 means, first we discussed about black body radiation. Next, we discussed about Planck's law. Planck's law is what, and what are the hypotheses or assumptions of Planck's law are what, that we discussed. Next, Albert Einstein, for this achievement, photoelectric effect, he got the Nobel Prize. What is that photoelectric effect? All this we discussed. Next, listing the topics first. Okay, as like this. Compton effect also we discussed. What is Compton effect? Compton shift means what? Compton shift depends on what, the parameter scattering angle only, and lambda dash minus lambda equal to what, that, and what is the uses or applications of Compton effect, what it exactly, what it exactly proved, that we discussed Compton effect. Okay. Next, waves and particles, what is the interrelation between particles and waves, we have discussed in this topic. Next, de Broglie hypothesis, matter waves. De Broglie equation, lambda equal to h by mv or h by p, and matter waves are what, their properties. Next, Davis and Germer's experiment also we discussed. List of topics, all these which will comes under the unit 1. Next, Heisenberg uncertainty principle also we discussed. Next, Schrodinger's time independent wave equation also we discussed, and the physical significance of wave equation psi. We are calling it as psi. Okay, it should be always represented in the form of a complex value only, so that there are some advantages are there. All the average momentum and the average energy of that particle can be calculated by taking the psi value as the complex value. A psi a, it is nothing but x plus iy form, that we have seen. Okay, probability density means what, that we have seen. That once again I'm going to explain about all this. Okay. Next, particle in one dimensional potential box. So what is this? In unit 1, these are all the topics are there. These are all the topics in unit 1. Now the question is, examination point of view, if you take, which question can be expected as under the short answer, and which question can be expected as under the long answer. Okay, short answer means, in general will be for 5 marks, like that you treat, and a long answer means you have to elaborate the things and you have to represent them, present them on paper in an detailed manner, and can be expected, these questions for 12 marks. So 5 marks and 12 marks. Short answer 5 marks, long answer 12 marks. As like that you can take. Okay. For semester end examination also, whatever now I am going to tell, they are going to be useful for you. Not only for mid examination, even for the semester end examination also. So short answer means 5 marks. It is nothing but half of the page minimum you have to write for 5 marks. If, for example, it is mid examination, half paper only. If it is final exam, then in general the evaluator will expect that answer should be in an elaborative manner. Why? Because in mid examination, short answer he only carries 2 marks only, but thing is, matter should be as it is. Matter should be elaborated only. Even they are giving the 2 marks, you have to write the definition, and whatever the diagram is that you have to write. It is nothing but whatever the main concepts of that topic are there, that you need to write without missing anything. Then you will get full marks. Whereas if you take the semester end examination, then the evaluator may expect even more in detail things actually. Then you need to write even elaborated manner to get that more marks, to get that 3 or 5 marks. Okay, so overall you treat that for short answer questions, you are getting the 5 marks, and long answer questions as the 10 or 12 marks, like that you take. Okay, now you see in unit 1, today I'm going to explain about unit 1 only, not unit 2 and third unit, only unit 1. What are all the important topics are there, and the tutorial problems, and the short answer and long answers which can be taken. Okay, now you see under unit 1, under unit 1, block body radiation. Explain about the block body radiator, right? Its properties, and Stephen Boltzmann law, whatever is there, which is explaining about the block body radiation. Explain about that as under the short answer question we can expect. Okay, this is the first question that can be predicted as under the short answer question. Black body radiation cannot be given, never been given this question as under the long answer question. So we can expect 80%, 90% we can expect even in semester exam also as under the short answer question only. Black body radiation means what to be written, that I will explain later. But thing is short answer question, this will comes under. Okay. Next, Compton effect also never been given it under the long answer question. Compton effect. But thing is, whatever the diagrams are there, Compton shift, Compton effect statement is there, and whatever the graphs, diagrams are there, that you need to draw. Don't think that since it is a short answer question, only 1 or 2 lines I will write. Don't think like that. Okay. So this can be expected as under the short answer question, maximum 5 marks question as like that. Okay. Next, third one is Heisenberg uncertainty principle. In first unit, these are all the topics actually. First slide I have shown what all the topics are there in a sequence. But the second slide, this slide, if you take, only the short answers are what and the long answers are what, that I'm going to tell here. Okay. So Heisenberg uncertainty principle will comes under the short answer question only. Never have been given as under the long answer question. Statement you have to write, that equation you have to write, and some more important points about the Heisenberg uncertainty principle you have to write. So cannot be expected that for long answer question. Okay. Next, the physical significance of wave function is there. Psi, physical significance of wave function, as I told you, complex value can be written as complex value, and by you writing as like that, there are some advantages. Probability density, what is that probability density? Square of magnitude of wave function. And by taking as like that, we can predict, we can guess, we can calculate the probability of that
Particle.
which is moving in a space of minus infinity plus infinity. What is that probability value that can be guessed? All these we have discussed, that can be expected as under the short answer question. So 1, 2, 3, 4 in first unit, these can be expected as under the short answer questions. Now, Planck's law never been given in any question paper as under the short and long answer. Cannot be expected, but thing is you must know what is this Planck's law. Okay. Next, photoelectric effect also never been asked as under the short or long answer questions. So you can keep aside for time being. Okay. So next one is waves and particles also, that it is just an interrelation between what is a particle, what is a wave, when can be said a particle as wave, when a wave can be treated as a particle. That is the concept only, basics only. That's why never been given. Now the blue color topics whatever are there, they will comes under the short answer questions. Black color whatever the topics are there, they never been asked as under the short and long answer question, they never been asked. Okay. Now, very important thing is in first unit, which topics can be expected as under the long answer questions. Very important topic is de Broglie hypothesis. Derive de Broglie equation and explain about which waves are called matter waves, and compare these properties of matter waves with the X-ray waves. and de Broglie hypothesis, in which applications are also there: case 1, case 2, case 3, case 4. So 12 marks or 10 marks question as under that we can expect in final examination. Even it is very important in mid examination also. De Broglie hypothesis up to applications, and what are matter waves, and writing about the properties of matter waves can be expected. Okay, if you have that notebook, classwork notebook, there it, then and there itself you can write which is which will which topic can be taken as under the short answer, and which topic can be taken as under the long answer question. Okay, now very very important, that is division Germer's experiment, complete experiment. Okay, what it is proving, diagram, and the working of that experiment, and the interpretation of results with X-ray diffraction results, and what is that final conclusion can be expected as under the long answer question. Okay, division Germer's experiment. Next, Schrodinger's time independent wave equation, we have derived that actually. Okay, that expression or equation, so many times they have asked as under the long answer question. What is that? Division Germer's experiment and Schrodinger time independent wave equation, and the de Broglie hypothesis, whatever the applications or cases are also there, that will also comes under. And in final exam, whatever the red color topics are there, many times they were asked as under the long answer question. Particle in a one dimensional potential box, eigenvalues, eigenfunctions, derive eigenvalues and eigenfunctions, formulate eigenvalues and eigenfunctions. Deriving is nothing but we are formulating. What is that formula? You are deriving that thing by taking a particle which is moving in a one dimensional potential box. How you have assumed, and by taking the Schrodinger time independent equation and applying that on that particular particle which is moving in some boundaries, as infinite boundaries are there. So overall particle in a potential box can also be expected as under the long answer question. Very 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 important questions these can be taken as under the long answer question. De Broglie hypothesis, even I can say that confidently, I can say that even in mid exam also you can expect these red and blue color questions as under the short answers and the long answer questions. Now the you might have a doubt that sir, these many topics you are saying as the important questions. Now how they will give, sir? Thing is the thing is limited questions only to be given na. How can be expected first topic black body and Compton effect and Heisenberg and then physical significance means, you know that for any mid examination whatever we are conducting, there are two sets are there, not a single set. In first set, the question paper if you take, few questions can be expected. In second set, whatever the questions that are framed, they won't be repeated, they are quite different questions. It is nothing but if you take two short answer questions can be expected in one question paper, two more short answer questions can be expected in the second set, set 1, set 2. It is nothing but set 1, if you are getting as the question paper, the next immediate student who sat behind you, he will get set 2 question paper. Set 1, set 2, set 1, set 2, like that pattern is going to be followed, just like an MSET MSET pattern. Okay, no one can get the same question paper surrounding you. Similarly here also, in our college we are framing two sets of question papers. That's why, for example, you take red color topics. If you take de Broglie hypothesis is there, division Germers is there. Might be the first two questions may come in set 1. Two questions, long answer questions have to be prepared. That's all. But remaining two, Schrodinger and particle in one dimensional as the long answer questions may come in set 2. You which you said you will get, nobody knows. Set 1 and set 2 you have to be prepared. It is nothing but can be expected. These are all the important questions. Among them, if you have prepared these questions, definitely you can answer either the first set or the second set, whatever the set that you got. Is it okay, students? Am I audible to you? Is it clear?
Yes, sir.
Any
Yes, sir.
doubts if you have now itself you can ask. This is interactive session only. Whatever the doubts that you are getting, you can ask. Now the thing is, in unit 1, as I told to you, these are all the important questions. Means blue color and the red color. Especially, let me take for mid examination only. These can be expected as very, very important questions. Damn sure you are going to see these topics as the questions. But in which set or which this thing will come, even I too don't know. But these are all going to be seen in your question paper. Now the thing is how that question paper will be. What is that pattern? First unit if you take, where it could be. Means these questions where they can be occupied. Where is that? It is nothing but here you see. See, set 1 is there. Set 1. Mid examination they have written long, it is nothing but last batch students, your senior students, January 2021. This question paper was framed by our college by the subject experts. See here, our college set number 1, like this set number 2 is also there. Set 2, set 1, two sets of question papers they will prepare, and all these two, set 1 and set 2, will be taken as printouts, and all they are going to be circulated to the students. 1 2 1 2 1 2 1 2 like that. Okay, so this exam is for 2 hours. Mid examination which are going to be conducted from 14th onwards. 2 hours exam, 10 to 12 exam time. If you take 10 to 12, here you see, you can see the subject code. MLR 20 are the regulations. MLR 20 means in 2020 these regulations are, and the pattern was formed actually as like this. Okay, set number 1, MLRIT, Autonomous College, and the subject name is Applied Physics. You are going to see the question paper as like this. Okay, and which branches will have this subject? That branch names can be seen here. Okay, maximum marks for 25 marks. This is a descriptive exam. We are calling it as. This is for 25 marks. Descriptive exam. Mid exams all are descriptive only. Descriptive means for a given question you are writing the answers on a paper as under the descriptive, not the objective. Okay, so this carries 25 marks. Any theory subject you take, mid exam carries 25 marks. Okay, this is for 2 hours. What about the other marks? Other thing is nothing but 5 marks for assignment. Whatever assignment questions that we have given to you, if you have answered them properly and submitted in time, then you are going to get 4 or 5 marks based on your presentation. Okay, so there you are going to get 5 marks free of cost. But thing is here you have to work hard. Okay, so 25 plus 5, total 30 marks for every subject. This is common. 5 marks for assignment, 25 marks for descriptive exam, 30 marks for internal marks, internal 13. External means semester end exam. That question paper is for 70 marks. Descriptive 70 marks, descriptive. Semester end examination we are calling it as. That is for 70 marks. Internal marks for 30. Out of 30, 25 descriptive, 5 assignment. Now you can ask the questions. If you have any doubts, you can ask Nana regarding this question paper.
Sir, pass marks.
See, for out of 30 marks, you must get minimum 15 marks. Minimum 15. Altogether, 25 plus 5, 30 are there, na? Out of 30, out of 30, if you got 15 marks, you have passed. 50% of the total marks. Treated as
For 25.
for not 25. Here you must see 25 plus 5, na? 25 plus 5 assignment marks. That is for 30. So total 30. Out of 30, you must get 15. See, for example, in assignment, you got 2 marks only. Then what is your target to pass here? In descriptive, how many you have to get? Minimum 13. So to pass in this descriptive, there won't be any limit. But thing is, how many marks you are getting in assignment, that will be considered. If you are getting out of 5 assignment marks of 5, for example, you are getting, then here 10 is enough. Minimum 10 you have to get here. If and if conditions applies, that is nothing but in assignment. If you got 100% marks, 10%, 5 by 5, then here 10. If there you got 2 marks, then target for you here is to 13. Is it clear?
సార్ అసైన్మెంట్స్ మార్క్స్ ఎగ్జామ్స్ ముందు చెప్తారా లేకపోతే?
అసైన్మెంట్ మార్క్స్ మీకు పోస్టింగ్ కూడా అవుతాయి బాబు, మీకు తెలుస్తాయి, చెప్తారు.
ఓకే
Assignment
సార్.
1, assignment 2, assignment 3, like that. For every unit, each every faculty member will give some questions as under the assignment. If you have submitted properly in time and the presentation is also good, then you can expect maximum marks out of 5, 4 or 5 you can expect. That are going to be disclosed to you, that are going to be announced to you, no problem. How many marks you got in assignment? See, overall, let us assume that you got there 4 only on our average. For example, I am telling, then here the 11. For example, here there you are expecting that 3, here 12 is your target. For every personal thing, that person to person, that target may vary. For example, all assignment questions you have written properly and you are confident that you are going to get 5 out of 5 in assignment, means here 10 only, like that. Okay. Now here you see, if you take this question paper, if you take this, all these are going to be applicable to set 2 also. Again, I am not going to take the set 2 question paper and not going to explain about all these common, these things rules are common. Now you see, part 1, it is nothing but A, part B. Two parts are there here, you see. Part A is nothing but short answer questions. How many are given here? Short answer questions, how many are given? See the screen and tell me.
Five. Five.
5 questions are there. 1A. Now, whenever you are writing answer to that particular question, what you need to do, margins are given. That out of that margin, leftmost corner, you have to write 1A answer. 1A is nothing but short answer, first question. You need to write about like this. You see how the question was framed here. So describe Compton's shift in Compton's experiment with a knee diagram. Can be expected this as under the short answer question as like this. Don't think that short answer means only 1 or 2 lines only have to be written. Don't think like that. Don't write the answer based on the how many marks that question is going to be carry. Whatever that you know about that topic, by maintaining the time, you have to present on the paper, then you are going to get good marks. Okay. Now see, 1A, 1B, 1C, 1D, 1E. No choice will be given in part A. No choice will be given. Means all these questions are mandatory only. All these questions are mandatory. You have to write all answers to given these questions. Now, how they are distributed unit wise means, first 2 questions you take, 1A, 1B will comes from, these are framed from unit 1. See, Compton effect is the first topic. Second one, matter waves, define matter waves is also will comes under the first unit only. So 1A and B, 1A, 1B, all are mandatory questions, compulsory you have to write. These two are framed under the unit 1. Next, CD you take, CD, they will, they were framed from unit 2. Unit 2, you see, define infinite negative effective mass, mention the expression for effective mass of electron. Only mention is nothing but the final, whatever the expression is there for effective mass of electron, that you have to write. And you need to define what is infinite effective mass, what is the negative effective mass, that is C, which will, this is nothing but the second unit question. D is also from second unit only. So two questions, first two questions from unit 1, second two questions from unit 2, and the third question is from unit 3 half portion 3a. 3a 3b, if you take like that, 3a is nothing but the first topic, first semiconductors, not the semiconducting devices. From semiconductors up to semiconductors na, so this can be expected from unit 3a. Likewise, the distribution will be there. Try to understand. Is it okay? Part A, all questions are compulsory. Each question carries 2 marks. All questions are compulsory. 5 questions are given. So 2 into 5. 5 questions are there. Each question carries 2 marks. So 2 into 5, total 10 marks. Each question carries 2 marks. 2 plus 2 plus 2 plus 2 plus 2, 10 marks. Out of 25, part A carries 10 marks. Part A carries 10 marks. Is it okay? Regarding part A. First two questions from
First unit.
unit 1. Okay. Second two, next two questions C, D from unit 2. And the E question is not but fifth question. First two are over, second two are over. This is from third unit. Like that, the distribution will be there. Don't think that all 5 questions will be given from a single unit only, or all questions will be given from third unit only. It is not like that. Distribution is done actually. Part 1 is from unit 2, and half unit only we have completed in unit 3 na, so only one question can be expected as under the short answer question from unit 3. I hope all you have understood. Now let me explain about the part B. This is part B. Part A, all questions are compulsory, but part B, if you take, this is about long answer questions. Each question, here you see, how many questions you have to write answers means you have to write three questions, you have to write answers. Three questions only. Internal choices are given. Internal choice is given. Each question carries here 5 marks. Each question carries here 6 marks actually. If you are attempting this, you are going to get 6 marks as like that. Okay, I will tell how you are going to get that remaining 15 marks from part B. Now you see 2a 2b is there. 2a 2b. Now this question, if you see, this is from which unit? Part B long answer questions. If you take this
Unit
question
1.
is from
Unit
unit
1.
1. Yeah, this question is from unit 1. Theory question. This is theory, followed by, you see, attached to this B part is there. B. These two are compulsory. If you are attempting second question, then you have to write 2A and 2B also. This is theory question and this is problem in unit 1. So second question, if you take, this is completely from unit 1 only. One theory question followed by problem. 2AB is nothing but this one question. It is nothing but two questions. Question number 2. A and B are the sub questions. Okay. So if you have attempted unit 2, if you have attempted 2A means you are going to get 3 marks. If everything is correct, they are going to give 3 marks. To B also you have to attempt. Why? Because A attempted means B will also be taken as granted. Means you have to write. That's all. This is nothing but a problem. Heisenberg uncertainty problem. This is. So if you have done this problem, if you have solved this problem, you are going to get 3 marks here. 3 plus 3. It is nothing but how many marks? 6 marks you are going to get. 6 marks you are going to get. Okay. It is nothing but 6 marks you are going to get here. If you have attempted 2A or 2A and B. Now this is from unit 1. Unit 1. Internal choice I told means, or if you want any choice means you can also write either 2AB you can write, or if you are perfect in this, then you can write 3AB. Either 2AB or 3AB you can attempt. If you have attempted 3A, 3B is mandatory for you. You cannot write 2A here and 3B here. You cannot write. If you have written as like that also, we are going to know that you have written as like that. While posting the marks, we came to know that thing. We are given 2A means 2B only we will see. We won't consider the marks of 3B. Why? Because either 2A or either 2AB or 3AB you have to write. Okay, that is very very important thing. Now this is 2AB is from unit 1 and R internal choice same unit 1. We are giving one more choice to you. 3AB will also comes from unit 1, unit 1 only. Now you see here matter waves, explain about matter waves, and deduce. Deduce means nothing but derive. The expression for de Broglie wavelength lambda equal to h by mv, and derive equation which is associated with a particle of mass m and its kinetic energy. M and ek relation whatever is there, that cases are there na. One of the case I am asking you to derive here. What is that? M and Ek. Where it is going to be seen? That equation. Lambda equal to h by under square root of 2m Ek is there. There you are going to use, it is nothing but I think it is a case 2 I think. Case 1 is P, momentum. Case 2 is if you know the kinetic energy, then if you know the mass of that particle. Case 2 I am asking. Derive the de Broglie equation and derive expression for case 2. That first question if you take. And this is a problem. Compulsory problem is attached to this theory question. Compulsory. Now deduce the Schrodinger's time-independent wave equation for a moving particle in one-dimensional and discuss the physical significance of wave function as under the long answer question. You have to derive the expression and you have to write about the physical significance. Think that long answer question carries 12 marks in final exam. Out of 70 marks, 12 marks you are going to get by writing the answer to that given question. Okay, and most thing more in most of the cases, any problem you take which will carry 3 marks. But in mid examination, theory and problem if you take, both are carrying the same mark, 3 plus 3. Equal importance is given to the problems also, given to the problem also. Only don't think that I will prepare few theory questions and I will write, then it is nothing but you are going to write, you are going to attempt half question only. Why? Because the remaining half is a tutorial problem. It is a problem. Compulsory theory and problem will come, which is attached to a theory problem, theory question. Okay, now 3ab is unit 1 only. Here also unit 1. If you are if you are attempting 2ab, then 3ab need not to touch. If you are touching 3ab, then need not to write the answer for 2ab. Anyone as the internal choice from unit 1, from unit 1. Okay, so unit 1 is over. Next question paper if you take, 4 and 5, 4 and 5 are given from unit 2, unit 2 with internal choice. Here R is there, here R is there. Means either 4AB you can write or 5AB. Here it is not mentioned, but thing is while copying might be it was missed, but in between 4AB and 5AB internal choice R is there, or R is there. If you are writing answer for this question, then compulsory you have to attempt the B part also, which is nothing but a problem. Okay, if you are writing 5A as under the theory question, then 5B is compulsory you have to write. Either this or this you have to attempt. This is carrying 3 marks, this is carrying 3 marks. Now you see, uh, if you take this, you have, for example, a student have been attempted 2AB, 3 marks plus 3 marks. How many? 6 marks are over. He cannot attempt this. For example, if he was attempted this, then he cannot attempt this. So it is nothing but this question 2 carries 6 marks, or 3 if you take, it is also carrying 6 marks. For example, If a student have attempted 2, 6 marks he got. Now 4 and 5, one question have to be attempted. Means again 6 he is getting. Any if he is attempting this, he is getting 6. Either this or this. It is but 6 plus 6, 12. Now this question, sixth question, if you take, which is only is having A or B. This will comes. This question is framed from the unit 3. Now you see what is Hall effect. Unit 3 actually, that is derive an expression for Hall coefficient and list the applications of Hall effects. This is theory question. Now, either you can write this or one problem is given in unit 3. Theory and a problem. Anyone can be attempted. Anyone can be attempted. Wherever R is there, either this or this you can attempt. This is for 3 marks. It is nothing but part A if you take for 10 marks, 5 into 2, it is nothing but 5 questions you are attempting. Each question carries 2 to 10 marks. Part B, long answer question. This is short answer part A. And here either you can attempt this or this under the unit 1. One theory, one problem definitely will come, but internal choice is there. Second unit also internal choice is there for it's carrying 6 marks. And third is this one unit. If you take 6A and B belongs to third unit, only one only will be given for 3 marks. Either theory or problem you can attempt. Is it okay? How the question paper pattern will be means like this. See these two model question paper. I'm saying these are the model question papers. Why? Because previous batch, if you take your senior students, if you take, they have written this question paper only. They have taken this as the mid examination paper. They have written. Okay, so you can take that previous question paper as the model question paper. Okay, like this. Okay, now so you know that uh, mid examination, if you take, this is the pattern. A is compulsory, B is having the some internal choice. Any doubts, students? Shall I move to the next topic? Now you know which topics are important in unit 1, that you know. Next, how the question paper pattern will be, that also you know. Question paper pattern and that what we call uh, which in which unit how many number of questions will come, that also you know. Next, let us move to the topics. What is that first topic? As I told you, black body radiation is there, and how can be expected the answer to the given question. Explain about the black body radiation and Stephen Boltzmann law. Like that question is there. First, you need to write the definition of black body radiation. Black body radiation definition. Which object is called as black body? And you need to draw that diagram. A black body radiator, what it can do, you need to draw this diagram. Okay, next, the properties of black body radiator, listing the properties of black body radiator, as like this you need to draw, you need to write. Okay, next, as I told to you, this is the black body radiator. Now ideal black body radiator, if you take, what are all that lamp black body we are calling it as, what are the properties of an ideal black body radiator? 9 with 99% efficiency it will work. How it was constructed, how we can assume that you need to write like this, you need to write. Okay, an ideal black body radiator, if you take, it consists of a hollow thick walled sphere, and internally black color paint is coated, and a small hole is given here, so that energy can be that energy can be entered into the radiation, energy can be entered into the that thick wall sphere. Okay, by again and again reflections, all the energy is absorbed by that black body radiator. None of the energy is reflected, neither transmitted. Okay, and only by heating that material now at a particular temperature, constant temperature, it starts emitting whatever the energy that it has absorbed previously at a constant temperature. So black body radiator emission radiation energy is dependent on the temperature only. It does not depend on the type of object. Like that you need to write. Next, Stephen Boltzmann law is there na, that what is that the amount of radiated energy by a unit volume of a sphere, unit volume of a space, that is E star, is directly proportional to fourth power of the temperature of that object. Then you need to write as this equation. This is nothing but Stephen Boltzmann law about the black body radiator. The scientist was explained as like that. The temperature, fourth power of temperature, whatever is there, the energy emitted is having relation as like this, where sigma is nothing but here Stephen Boltzmann constant we are calling. That value can be expected as like this. So emitted radiation by that black body is directly proportional to the temperature. As you go on increasing the temperature, it starts emitting the radiated energy as like this. You can write. This is about Stephen Boltzmann law. Okay. And also you need to draw this diagram. How much time it will take? Matter of 3 or 4 minutes only to write about all this. If you know everything, simply you can write as like this. Here emission energy, here wavelength, and the temperatures and peak points to be written as like this. You have to draw. This is the answer for the first question, whatever was given as under the short answer question. Okay. Now, applications of blackboard radiator. One or two applications are enough. As solar collectors, energy collectors we can use, and infrared thermal detectors as we can use, and far away distance objects temperature if you want to measure, we can measure by using the blackboard radiator, can be taken as the applications. Okay. Next in this unit, we have one more topic. What is that? Planck's law is there. Never been asked this Planck's law, but you must know why, because it is very very important actually. Okay. So what is Planck's law? Quantum theory of radiation we are calling. What it explains, that material already you are having. Okay. So this is very important. Assumptions of Planck law. Assumptions of Planck law. What is that is important. Okay. So black body radiator can able to radiate. Black body radiator can able to radiate or emit the energy. What is happening inside that material was successfully explained by a scientist called Planck. According to this scientist, a black body radiator will have a large number of atomic oscillators. Like that, by assuming he has explained about the properties of a black body radiator. Why a black body radiator will behave as like that? He has explained actually. By treating that a black body radiator contains a large number of atomic oscillators. And all these atomic oscillators are continuously they are in vibration, simple harmonic vibration with some frequency they will have. Okay. And if you take these black body radiators, they cannot emit or absorb energy continuously. They can absorb the energy, they can emit the energy, but thing is continuously they cannot be emit or absorb. Okay. In a discrete manner, in a discrete values only they will emit or absorb the energy. Releasing the energy continuously is not possible, but with a patterns, it is nothing but h nu 2 h nu 3 h nu 4 h nu, like that they can release the energy. That is very important. Third point, don't get confused. Oscillators cannot emit or absorb. If oscillators cannot emit or absorb, then how the blackboard radiator will emit or absorb the energy? Means continuously it is not possible. Breaking, it is nothing but with certain values, discrete values, energy can be emitted. That energy he was calculated. Planck's was calculated that energy. That energy is in the form of n into h nu. E equal to n into h nu as. That's why it is called E equal to h nu. We are calling E equal to n into h nu. It is nothing but in order of h nu, energy is emitted if at all a particle is vibrating with some frequency. I like this is nothing but Planck's black body radiation. Okay, and whatever the assumptions are there, n equal to 1 if you take 1 h nu, 2 h nu, 3 h nu, discrete values of emission of energy can be expected as like that. E is directly proportional to nu. E is equal to, if I writing means Planck's constant should be introduced here. E is equal to h nu as like that. Okay, h value he has calculated as h equal to this much value. These are all already you know. Only thing is once again you need to write them. Okay. So whatever the assumptions are there, you need to listed them. Already you know E equal to N into H nu. What is H? What is F? What is N? That you are writing. Energies are quantized, we are calling. Not a continuous form of release of or absorption of energy, but in a discrete manner, quantized manner, energy is going to be released. That is Planck's law we are calling. According to this scientist, the energy released is dependent on the wavelength of the that energy. Okay, E lambda we are calling. Energy is function with wavelength is equal to, he has derived one expression. This is called as Planck's equation we are calling in terms of lambda. In terms of nu, E equal to h nu. In terms of lambda, he has calculated as like this. Okay, that we need to write. What all the terms are there? Okay, that is Planck's law. Okay, next photoelectric effect. As I told to you, this is very important, and for this achievement, this scientist was got Nobel Prize. And overall, what is going to be happen is photo is nothing but light. Light energy is converted into electricity. How? Means it is nothing but an experiment only, in which here is a light energy is incidented on a two plates are there, a plate A and plate B. High sensitive metallic plates, these two are high sensitive plates, metal plate A, metal plate B. Light energy is incidented on that metal plate A. Then due to the low ionization energy, metal plate A, by absorbing that light energy, electrons get accelerated, and they were excited, and electrons are going to be ejected from this plate. Ejecting is nothing but coming out. Just they were becoming as the free electrons, but they do not have the acceleration. They cannot move. To move these electrons from this plate to this plate, we are applying the voltage across that two plates. This is called as voltage stopping potential. We are calling the minimum amount of voltage required for successful transferring of electrons from metal plate A to metal plate B is called as the stopping potential. And the minimum energy, the minimum wavelength of the radiation energy is called as a threshold wavelength, and minimum frequency is called threshold frequency. So threshold wavelength, threshold frequency, and stopping potential are the three important terminologies in photoelectric effects. Okay, so about this experiment, it consists of two plates, metal plate A and metal plate B, and these two plates are kept in a quartz or bulb evacuated chamber, and a negative terminal is connected to the metal plate A, positive terminal is connected to metal plate B, and an ammeter is connected so that to measure the current which is flowing across that metal plate A to B. That we need to write. Okay, once if you go through, you came to know all these things. Okay, and working when you on this voltage, when voltage is applied, then after moving from one plate to another plate, if they have successfully reached the second plate, then current can be observed in the ammeter. Okay, it is nothing but light energy is taken as the input, and output we are getting as the current. It is nothing but photoelectric effect we are calling it as. Okay, okay, and the three important terminologies are there. What are all they? And the movement of the electrons, photoelectrons depends on what parameters. Only thing is you need to write as like this. Okay, and there are three important these things are there: work function W naught, threshold frequency nu naught, threshold wavelength lambda naught, and the stopping potential V naught. Their expressions also we have derived. If at all this question comes, you need to write E equal to what, that thing you need to write. Very easy. E equal to H nu equal to C by lambda. So nu naught equal to C by lambda naught. Nu naught is the threshold wave is frequency, lambda naught is the threshold wavelength. Like that we can write, no problem. Okay, so already we discussed long back itself about these questions, these things. Okay, now stopping potential also we have derived from 1 and 2 equations as V naught equal to H by E into nu minus nu naught as that. How? Already you know that. Okay, So photoelectric effect means like this we have to write. And what is the advantage with this photoelectric effect? Light energy is converted into electricity. By knowing this only, solar panels were developed. Light energy is taking it as input, and we can able to generate the output as the electricity. Photo switches, detectors are the best examples. Those devices which are operated by the light as input, they will comes under the photoelectric effect only, since photo is the input. Okay, that is about the photoelectric effects. Okay, next. Any doubts in meanwhile you can ask. Compton effect. What is Compton effect? We have seen. Okay. What is that? First, you need to write the statement. What is that? Compton effect is an experiment which is done by Compton and Debye, and this experiment is going to be proved. It is nothing but an experimental evidence of particle nature of electromagnetic radiation. Particle nature of a wave. Electromagnetic is nothing but X-ray waves were selected by these scientists as the input. Okay, and that statement is this one. Compton shift means what? What is shifting is nothing but lambda is the input wavelength of X-ray beam. After scattered by this graphite, this X-ray beam is changing its wavelength. That is, extended wavelength was observed. Extended means increased wavelength after scattering. Lambda dash is the increased wavelength. Lambda is the incident wavelength. Lambda dash minus lambda is equal to some value they have derived, that is h by m naught c into 1 minus cos theta as. Okay. So this experiment, you need to draw this diagram, and the definition you have to write. And what is this Compton shift? Shift means this one. H by m naught c into 1 minus cos theta. In terms of sine also we can write na. How we can write? As like this we can write. Okay. And there are some graphs also, graphical things are also there. Compton shift directly proportional to the scattering angle. Scattering angle. Okay. So scattering angle versus the Compton shift means theta equal to 0. Scattering angle is 0. No Compton shift. If theta equal to 45 degrees, bump can be expected. Means initial value changed, extended that wavelength. This difference is nothing but the Compton shift. You see, as the theta is increasing, the distance between these two is also difference is also increasing. Theta equal to 180 means maximum shift can be expected. So they are all nothing but the observations actually. They are all nothing but the observations that you have to write by plotting these graphs as like this. Okay. So Compton effect, what are all the applications are there? By knowing that phenomena, what we can do means these are all the applications of Compton effect that we can write. Okay. Wave and particle, already you know, never been asked what is a particle and what is a wave, but thing is what is the interrelation between them you have to write. When particle is stationary, it is just a particle only. All properties of particle we can see for a stationary particle. Particle will have mass, particle will have position. Properties of particle: particle will have velocity, particle will have momentum. Okay, all these are the properties of particle. Okay, now particle will have energy. These are all the properties of a particle. When the same particle is moving, then we are not so no more calling it as a particle, we are calling it as a wave. Then wave properties are applicable to that moving particle, such as wave properties: amplitude it will have, frequency it will have, wavelength it will have, phase it will have. As like that we are saying same particle, but it is having different properties. Okay, so that is wave and particle nature we are calling. Okay, so that we have already explained, need not to explain once again. De Broglie hypothesis, as I told to you, long answer question can be expected. Okay, de Broglie expression, whatever is there, this is de Broglie hypothesis. When particle is material particle is stationary, it is just a particle only. When same particle is moving, material particle like electron, proton, and atom, when they are moving, then they will move like a wave. This is called the dual nature of material particles. Okay, so how we can derive that de Broglie equation means by taking the Planck's radiation law, and also by taking the energy mass relation equal to mc square equal to h nu. E, comparing these two, E1 equal to 2. If 1 equal to 2, the right terms whatever are there, they can be also equalized. When right terms are equalized, we can write as like this. So where lambda equal to, we can write as like this. For a moving particle, if the mass is m, then we can write as like this. That is nothing but lambda equal to h by mv or h by p. Lambda is called de Broglie wavelength. That also we know. Case 1, momentum. Case 2, as I told to you in that question also it was given. What is case 2? Relation between kinetic energy and mass of that particle with respect to wavelength. Case 2. This have to be derived. De Broglie equation and case 2. This have to be derived. Okay, like this questions can be expected. Okay, next case 3, if particle is experiencing some potential energy v and it is moving, then how we can expect wavelength, how much it has produced, lambda equal to in terms of charge and applied voltage. If particle is know that it is an electron only, then what is that produced wavelength by that an electron by applying the potential energy V, 12.27 by capital V under square root of capital V. They will comes under the applications of de Broglie equation. Okay, as I told you in that question paper also you have seen matter waves, definition of matter waves. Electron when it is moving, whatever the produced wave is there, that is called matter wave only. Means material particles such as electrons and protons and atoms when they are in motion, whatever the wave that they have generated are called the matter waves. Okay. Properties: short range, they cannot travel long distances, but they will be diffracted. Interference can be expected like electromagnetic rays. But thing is, when you compare the X-ray waves with matter waves, these properties can be expected. Less penetration depth, high scattering coefficient of matter waves. Okay, that is very very important. Now, Davidson-Germer's experiment. Draw this diagram. You have to draw this diagram. Okay, dual nature of material particle. When electron is moving, then it will move like a wave, which is explaining about that means Davidson-Germer's experiment only. Okay, draw this diagram, list out the apparatus, and write the working of this. When power is on, electrons are generated, nickel crystal is used as a target, all these are there. Comparing this lambda value whatever you got from the experiment, we are comparing that with another known X-ray diffraction method. Both are same is nothing but here X-rays are used, their movement of electron was taken. So when electron is moving, it will move like a wave. Since X-ray wave, X-ray is wave, it has got this value. But electrons when they are moving, whatever the value they got, they are also same. Means if results are same, the above whatever the particles are there, they are behaving as the X-ray waves only. So electron is moving, it is nothing but it is a wave. Like that, wave nature can be explained. Heisenberg uncertainty principle, just definition only. It is very easy. What is Heisenberg uncertainty principle? Momentum versus uncertainty in momentum. Finding the particle, uncertainty in momentum, uncertainty in position. Finding them both at a time when particle is moving is impossible. According to that, lambda x, delta x and delta p product is greater than or equal to h by 4 pi. This is Heisenberg uncertainty principle equation. Okay, using this there are some problems are there that you can solve them. Okay, next, Schrodinger's time independent wave equation. This is the expression that you need to derive. Okay, this expression how means when particle is moving in one dimensional, then one dimensional moving particle equation can be written as when particle is moving in one dimensional. This equation we are writing. We are differentiating this with respect to position x. Again differentiating. Then again we are calculating the total energy in terms of that momentum values. Then substituting that value in that. Overall, how we can convert that expression one dimensional, three dimensional, del operator by using how we can write simplified manner, that is Schrodinger time independent wave equation. and also physical significance of wave function. Okay, sound waves in what property is varying, matter waves if you take which property is going to be vary, and how we can represent SI in a better manner, means as I told to you here in the form of a complex one, complex it is nothing but x plus iy form. Then psi star is nothing but x minus iy. It is nothing but psi star will give a real value. Probability density is what? If at all the particle is moving within minus infinity plus infinity, definitely we can locate that particle. So probability of finding the particle in a given space, if you want to know, by using this expression we can find out. This is called normalization condition, we are calling it as. Okay, by using this what we can do, that also last topic, particle in a potential box, very very important question this is, damn sure. Okay, eigenvalues and eigenfunctions of a moving particle in terms of a potential box we have calculated. Okay, we have derived that expression. Okay, by taking the Schrodinger time independent wave equation and applying this equation to that moving particle, v equal to 0, since inside that particle, inside that box, part wave potential energy is 0. Okay, now this term we are taking as a k square. By taking as like this, finally we have derived the expression. What is that expression? Eigenvalues is they are nothing but the all possible energy levels of a moving particle as En equal to, we have calculated one, we have taken one value. What is that? Here you are getting, going to get k value. That k value you have to substitute in the above equation. Finally you are getting this one, you see, En equal to n square h square by 8ml square. Okay, eigenvalues, all possible energy levels of a moving particle when particle is in motion. Okay, so this is eigenvalues, and this is nothing but the eigenfunction. Psi n is called eigenfunction. First excited energy level, second excited energy level we can find out. Similarly, eigenfunctions also can be calculated. Psi n equal to a sin kx is there. K value is plus or minus n pi by L. Substituting here, where n values are 1, 2, 3. By taking as like this, n equal to 1, first eigenfunction, second eigenfunction, third eigenfunction for first excited energy, second excited energy, third excited energy, as like that. Okay, overall this diagram you have to draw at last. This is nothing but, this is nothing but the wave function. Okay, and these are all nothing but the eigenvalues. Okay, that is about the theory part, means whatever the important questions are there, and just a glance only within hour cannot be explained all the 8 or 10 topics, but thing is a glance of all these topics under the unit 1 can be explained as like this. Okay, now what all the problems are there in this unit 1? Calculate the stopping potential, very very important problem this is. On stopping potential you are going to get one problem. Compton scattering you are going to get this as modal problems, modal, but maybe numerical value vary, but like this only problems are going to be expected. Unit 1 problems, stopping potential problem, Compton scattering, Compton shift problem. Not only that, Heisenberg uncertainty on which one problem, and eigenvalues. Eigenvalues means here lowest energy level and the first excited energy level particle in a potential box. Okay, so the like these 5 problems are there. Maybe the numeric problem, numeric values may vary, but overall you are going to get these are all as the problems. Any doubts, anything you want to ask, you can ask within 40 minutes or 50 minutes. Explaining about the unit 1 as under all the tutorial problems and the question paper, might be it will take time as like this. Okay, anything you want to ask, Nana? Is it okay? Question paper pattern have you seen?
Yes,
Yes,
sir.
sir.
Okay, and what are the important questions that also you have seen, and the tutorial problems what can be expected under this also you have seen. If you want to take a screenshot you can take, no problem. Like this, problems, equal importance is given to the problems also. Theory you are writing, you can write, but followed by a problem will also be there. It is mandatory question, compulsory question. A, B. B is always a problem. B bit always a problem only can be expected. Okay. This is these are all the problems can be expected under unit 1. I hope all you have taken the screenshots or the photocopies. It's up to you. Okay. Now let me take the attendance by pasting this thing. That 35, 62 are they present? One more student is also there who has not yet submitted the form, that Google form for JNTU. Is he present? 35, 62?